In this video, I'm going to talk a little bit about complex numbers because it's another one of those things that we all learned long ago in high school and that doesn't come up very often, so you may have forgotten. Before I can talk about complex numbers, I have to remind you about imaginary numbers, which I love because they sound magical. The imaginary unit is I, which is defined to be, well, actually, it's defined by the fact that the square root of I is -1. So actually, both I and -I squared equal -1. And I is called the imaginary unit, or the unit of imaginary numbers. I just think of it as the imaginary unit. Anyway, it's called imaginary because it's not a real number, right? And the real numbers are basically any number. If you imagine a number line, it's got 0 in the middle, and positive infinity at one end and negative infinity on the other end. All the real numbers can be defined as occupying some point on this line, right? Imaginary numbers do not, because the square root of -1 is nowhere on this line, because negative numbers don't have square roots that are real, but they can have imaginary ones. But this is supposed to be about complex numbers. So a complex number is any number that has both a real and an imaginary part, by which I mean some complex number can always be written in the form a plus b times I. Some real number plus some other real number times I. And a is typically called the real part, and bi is the imaginary part of a complex number. So you might see a complex number like 2 plus 2i, or 3 minus I, but they'll always have this sort of two-part looking thing about them. Another way to think of complex numbers is as points where your axes are, let's say the x-axis is the real axis and the y-axis is the imaginary axis. Then any point, right, let's say, got some hash marks here, this point right here is going to be 2 plus 3i, right? Because on my real axis I've gone 2 points, and on my imaginary axis I've gone 3. In this perspective, you can also plot complex numbers using polar coordinates. But I don't want to get into polar coordinates right now because that's a whole other video. For the most part, complex numbers behave just the way a real number would behave, except for the fact that it's a little bit counterintuitive that it's the square root of -1. But if you encounter them out in the world, the best thing to do is just, so in standard algebra, when it shows up, leave all the i's as if they were other unknowns, right? As if they were some other x or y or variable thing. And then at the end, substitute -1 for all of the I squareds. That's basically why imaginary numbers are around, because there are a lot of situations where you want to take the square root of a large expression and it's got a -1 in it somewhere, and it would be really great if there was a square root for -1, and there isn't a real square root for -1. And in fact, there are lots of different polynomial expressions that don't have square roots that are real, but complex numbers actually make it so that every real number has complex square roots. Right? Like -9, the square root of -9 is 3i, or -3i, right? And that's why a lot of time in other parts of algebra you'll notice people are really concerned about finding real roots of some expression, because complex roots are guaranteed to exist, but real roots are not guaranteed to exist. The other thing I wanted to tell you about complex numbers is about complex conjugates, which are pairs of complex numbers that look like this. So if I've got a plus bi, its complex conjugate is a minus bi. So if you've got, and oftentimes we'll call complex numbers by z for some reason, so if you've got z is equal to a plus bi, its complex conjugate will be z star, which is a minus bi. And complex conjugates can be handy because if you multiply them together, z times z star, the answer will always be a real number. Because, let me just do this quickly for you. So, where shall I do that? Down here. A plus bi times a minus bi equals a squared plus abi minus abi minus bi squared, which just leaves you with a squared, those two cancel, plus b, because I squared is -1. Isn't that handy? If you ever really need to get rid of complex numbers in some expression, knowing that you can multiply them by their complex conjugate is handy. But that's pretty much it. I just wanted to remind you that complex numbers are a thing, that they all revolve around I, which is the square root of -1, which is imaginary.